I'm Angela, VP of Business Development at IONET, and we are on a mission to create the world's largest GPU cloud for AI applications. And we're currently on a mission to put over 1 million GPUs in a single DePIN through decentralized distributed computing. So I'm sure, as you've all seen, with the skyrocketing rise in demand for compute power, GPUs have effectively become the most valuable commodity in the world. And in fact, the CEO of Intel called GPUs as the new oil. Lightspeed AI adoption has truly been accelerating the need for these compute resources. As you see on the graph over here, while it took Netflix and Spotify over a decade to reach over 100 million users, OpenAI was able to accomplish that in less than 2 months. Instacart and similar enterprises of that scale are also deploying thousands of models themselves. For Instacart, for example, they deployed tens of thousands of models for predicting delivery times, planning the supply of couriers, as well as optimizing routing models for shoppers. And as another example, on Hugging Face, a very popular DevOps platform that we've seen, this is a little outdated. There's actually over 350,000 models on Hugging Face today. And all of these are actually done by not just early stage startups, but also individual machine learning hobbyists who are taking advantage of all of the low code dev platforms that are out there to start deploying their own models. And so this has resulted in compute requirements for AI increasing by 10x every 18 months. However, supply in the traditional cloud has only doubled over the same period. And this has ultimately resulted in the cost of AI to soar. And if you see the projected hardware spend driven by AI, I've actually seen personally when talking to early stage startups and our clients that it's not really unheard of to spend over 80% of your OpEx on compute resources alone. Larger enterprises like OpenAI spends millions of dollars just on GPU resources. And so we see a massive problem today where the already existing supply shortage of GPUs in the world has been very much exacerbated by the rise of the AI revolution. You know, in the crypto community, we've also placed a lot of supply constraints on GPU resources as well when it comes to mining farms and those types of activities. And then as we saw with the launch of ChatGPT and all of these rush of new startups popping up in the AI space, this has only exacerbated the need for compute resources throughout the world. And that's where IONET comes in. We take advantage of underutilized compute resources from independent data centers, crypto mining farms, and even consumer GPUs from anyone with additional compute capacity at their at-home computers or laptops. And we actually support some mobile GPUs too, so we have a lot of diversity there. And so IONET Cloud is our GPU network. It's also the place where engineers can seamlessly deploy a GPU cluster of any size and any scale, and they can just choose configurations which are very seamless UI to go ahead and deploy their GPU clusters and get their models up and running. So like I said, by taking advantage of the underutilized GPU capacity, we're building the world's largest AI decentralized GPU cloud. We're currently at over 25,000 GPUs on our network, and so I think we could honestly argue that we are already the world's largest decentralized GPU cloud, but we want to become the largest GPU cloud overall and compete against centralized cloud providers. We also have, and I'll show you in a demo video at the end of my little spiel here, but with a single click of a button, engineers can deploy a GPU cluster of even up to 20,000 or 20,000 GPUs and truly harness the power of our global network with a single click of a button. And so what we're building, or what we have been working on since we launched in November of last year, we're offering services that are ultimately better, faster, and cheaper. By aggregating supply from all over the world and taking advantage of the underutilized compute capacity, we're able to provide services that are up to 90% cheaper than centralized cloud offerings. We can also provide near instantaneous cluster deployment. Originally, when we started, you could deploy a cluster within 90 seconds. We've since improved our platform, and now you can deploy a cluster within 40 seconds now. And our permissionless architecture means that engineers don't have to face long KYC processes or wait times in order to get their GPUs. Instead, you just come to our platform, sign up, and you can get started just in a few seconds as soon as you make your configurations. Then on the flip side, we have IONET Worker, and this is where suppliers can contribute their hardware capacity and start earning on their hardware. And so we put your GPU farm to work, or you don't need to have a farm. We can put your computer or your laptop or whatever additional compute capacity you have to work. This is a snapshot of what the interface looks like on the IONET Worker side, where you can keep track of your reputation score. That represents your uptime, your device uptime on our network. We also show your connectivity speed, overall performance to allow you to keep track and monitor your device performance. We also have a page where you can keep track of your earnings and rewards as well. And so we allow you to maximize your infrastructure, and we've found that we can offer up to 15 times more earnings through IONET on average than with your average crypto mining returns. I'll get more into that later. And so when you look at other types of GPU aggregator projects, I'm sure you've seen a lot of them either at ETH Denver or just on Twitter, or if you've been, staying on top of all of the latest buzz around crypto. There are a lot of other GPU projects that are out there, but what makes IONET special is this concept around clustering. And so when you're thinking about an AI startup, even if you're very early stage, once you're at that level where you're no longer a hobbyist just cranking it out in your basement or your garage, and you're now ready to create a team, you're ready to train your models, have a proof of concept going, all of that, it's not enough to have access to just single instance GPUs. Single instance GPUs is just another word for sort of like single server machines. A server machine can typically host up to 8 GPUs per server. And so that can be enough in some use cases. Let's say you're just trying out, you might not be an engineer, but you just want to try out creating your own model, but you don't want to pay exorbitant prices to access compute. A single instance GPU could be attractive for you, and AWS, for example, offers things like spot instances where you can rent out GPUs for a short period of time on demand just to power your model. However, when you're thinking about scale and you're now at a company stage, you're a startup and you're ready to go, single instance GPUs are not enough. You need something called clustering, where you can take GPUs and put them together. We're talking about 50 GPUs, 500 GPUs, 5,000, tens of thousands, hundreds of thousands of GPUs, depending on your workload needs. You want to deploy them together, cluster them together, and orchestrate them so they're working together in concert. Now, you can create clusters in the traditional, in a centralized cloud, where they have massive data center infrastructure, they have huge server rooms. All of these devices are interconnected, all these GPUs are interconnected with each other. And so in that sense, you can create sort of like that traditional GPU cluster. What IONET can do is we can create virtual clusters, and we can take GPUs from all over the world. If you're an engineer and let's say you went through IONET Cloud and you've made all your selections, you selected what GPU model you wanted, you selected your location for your devices, your connectivity speed, security and compliance level, all of that. Then we can go ahead and our platform automatically groups together the GPUs that matches the specifications and clusters them together regardless of the location. So we can take GPUs from Tokyo, from Lisbon, from New York, from San Francisco, from truly anywhere in the world, and deploy them together and orchestrate them together so they're working like sort of like a single potent supercomputer of GPUs that are processing all of these workloads in parallel. And so that really allows us to take advantage of all of the underutilized compute capacity that's out there in the world. And we not only, let you use the GPUs, but we have that managed services component on top of that, so we can orchestrate those devices all together so they can actually tackle and process ML workloads. And so this is an exciting snapshot that I want to share with you. So this is our 2023 report. Mind you, we launched in November, so this is just the first 2 months of launch. And our metrics here just shows the traction that we have in the market and how our value proposition is truly resonating in the AI space, as well as with our suppliers as well. So we cover over 40 different countries. The graphics here says that we have 20,000 GPUs total, but since then we have now grown to 25,000. And in 2023 alone, total earnings have amounted to $185,000 over the course of those 2 months. Since then, we've grown that by about 50%, and our IO workers have earned over $350,000 on our platform. And all of this information, you can go to IONET Explorer and see what live stats are looking like. We've also launched BC8 AI, and that's a stable diffusion generative image app that we created to truly showcase the full potential of our platform. In BC8.ai, all of the training, fine-tuning, and inferencing has been fully powered by IONET, really showcasing that we can support your models truly end-to-end. So showtime. I had a little demo video here that I wanted to show you. In the conscious of time, I might need to skip some parts of it, but I think we're ready to start. Yeah? No. Business development at IONET. Okay. I'm really excited to share a demo presentation of the IO network. Since we launched to the public on November 3rd of 2023, we've been revolutionizing AI compute as we know it through decentralized distributed computing. Today, I'll walk you through IONET's 3 core elements. IO Cloud, where AI companies can seamlessly deploy their GPU clusters. IO Worker, where compute hardware facilities can provide their GPUs to the network. And IO Explorer, where you can see everything happening in a network from clusters to inferences and all of the microtransactions behind them. Each element has a simple and intuitive UI to ensure a frictionless user experience. Let's start with IO Cloud, where engineers can seamlessly deploy GPU clusters at any scale to power their AI compute needs. IO Cloud is truly pushing the boundaries of innovation. Engineers don't have to wait 2 weeks to do KYC or 3 weeks to access their GPUs. Instead, with their fully permissionless architecture, at IO you are only 40 seconds away from deploying a 20,000 GPU cluster. We are here to serve your model end-to-end, from training to inference, and provide a solution to most of your problems. First, connect your Solana wallet to top up your balance in USDC. You can also make your payments through credit card in fiat payments. Now, deploying a cluster in IONET is a really simple and quick process. Once you make your feature selections, your cluster will be deployed within just 40 seconds. Let's click on Deploy Cluster. And we currently have 2 powerful options, Ray and Kubernetes, along with the Mega Ray cluster option. And we have even more integrations in the pipeline, like Ludwig, Ray LLM, PyTorch, Hugging Face, along with Unreal Engine and Unity streaming to really expand our use cases and applicability of our network. In this example, let's deploy a Ray cluster. First, select the cluster type appropriate for your model. General workloads, training, or inference. Then select a supplier type. Each supplier has different specifications. IONET to access high-end chips in a data center, Render for light workloads for massively distributed tasks, and Filecoin for data-intensive workloads. Select your GPU model. We cover a diverse range of NVIDIA cards from high-end RTX series and all the way up to A100s and H100s. We're also the first cloud provider that can cluster Apple chips, M1, M2, and M3, along with the Max, Ultra, and Pro variations of all 3. Apple chips have a powerful neural engine and high memory bandwidth that makes these types of hardware attractive for AI use cases. And now with IONET, millions of Apple device owners can contribute their compute capacity and start earning on their hardware. Choose one. After you select your GPUs, let's say for this example, I wanted to do the 3090s. Select the location for your GPUs based on your needs. Maybe you want to bring inference closer to your users, or if you have low latency ML-powered quant algorithms, you'll probably want your devices to be close to stock exchanges. Or if location isn't that important to you, you can select all of the ones that are available for the type of GPU that you select. So here, I'll just go ahead and select all of our options, and you can see a snapshot of all the regional coverage we have. We currently cover 40 different countries, and our regional coverage is expanding by the day. Then select your level of security and compliance. Your model graphs and weights are end-to-end encrypted by default so that no one can access them. In addition, all of the data traffic in transit between the GPU workers is TLS encrypted as well. We also have SOC 2 as an option, and we've been partnering with enterprise-grade data centers with SOC 2 compliance to ensure the highest level of security. Then, select your desired connectivity speed. This way, you only pay for what you need. If you want to save on connectivity, you can simply select the lowest speed. If speed is more critical, you can select the higher tiers at a more premium price. So here, I'll go ahead and select high speed. Select your appropriate cluster purpose with our out-of-the-box configuration that will be ready for your existing code base with no additional setups. Since we're deploying a Ray cluster, I'll select Ray app. As you can see, we have several more integrations in our pipeline that is coming soon. Now we just have a couple steps left and your cluster will be ready to deploy. First, you can go ahead and name your cluster. As a default, your cluster name is pre-populated based on the configurations that you can select, but you can easily rename it here. So for example, I'll go ahead and call this ETH Denver Demo. Enter how many GPUs you want in your cluster and select how long you want your cluster to run for. You can select your duration on an hourly, daily, or weekly basis. So in this example, I'll go ahead and select, let's say, 6 GPUs, and I'll deploy it for 10 hours. Now at the bottom of the page, you can see the average price per card for the cluster meeting your specifications, as well as how much this entire cluster will cost you for the full duration that you selected for. Then click deploy, and your cluster will be ready in just 40 seconds. And that's it, a simple and quick process. Our system is fully permissionless with no KYC and no limitation on the quantity of GPUs that our clustering can support. You just need to make your selections and IronNet takes care of the rest. We'll go back here a few minutes later just to check on whether or not this cluster was successfully deployed. But for now, let's go into our Kubernetes page. IronNet currently supports Kubernetes along with Ray, and deploying a Kubernetes cluster is also a very similar process. Available nodes for Kubernetes on our platform have ultra high-speed internet of at least 2 gigabytes per second download and upload speeds, as well as SOC 2 compliance. All of the decentralized Kubernetes clusters come with pre-configured master nodes and workers at the highest level of security and specs available on our platform. The first configuration you can select is your supplier type. So for here, let's select IronNet. And after that, select the Kubernetes operator you'd like to activate on your cluster. Finally, similar process, you can enter your SSH key access, name your cluster, select a duration and a quantity for your devices, and then click deploy, and your cluster will be ready for you shortly. Now the cluster page shows all of the clusters you deployed on our network. And as you see here, the ETH Denver demo cluster was successfully deployed. When you click into a specific cluster for an overview of its specs, you can also see the performance of each worker device in your cluster, as well as the amount that you've paid so far. So for here, you can see the worker nodes that are comprising our 6 GPU cluster. Now, the most exciting part of this page is in the dev environment, where you can deploy your code with Visual Studio or Jupyter Notebook, and keep track of distributed computing and parallel workloads deployed on your cluster through the Ray dashboard. Playground is also an exciting visualization feature where you can play around with your cluster and test it out. You can add or remove neurons and see how that affects your cluster performance. Now, let's go into IO Worker. This is where suppliers can connect their devices, monitor them, and keep track of their accrued rewards. To connect your device, first, click on Connect New Worker. Onboarding is a fairly intuitive process. The very first thing you do is select your operating system, Mac OS, Windows, or Linux. In this example, I'll select Linux. Select your supplier category, IronNet for enterprise-grade GPUs, and Render if you have consumer-grade GPUs. Name your device, so I will call this Angela node. Select your device type, whether you are a GPU worker or a CPU worker. And now all you have to do is follow steps 5 and 6. Just download the scripts to install our containers and run the command to start them. And once your devices are connected and all of the proper containers are installed, this button will automatically refresh, and then you'll be able to see your devices after that. Now, this entire process should only take a few minutes. Then when you go into your devices page, you can actually monitor your devices here. Let's click on one of our nodes as an example. And here, you can monitor your device's activity and keep track of your reputation score that's driven by your uptime. So this score, the higher the score it is, the more jobs that you'll get allocated towards you. Now, finally, the earnings and rewards page allows you to monitor and withdraw your accrued earnings. Once you set up your account, connect your Solana wallet to IO so that you can claim your rewards. You can also view all of the compute jobs your devices have been hired for and keep track of how much you've earned. Join IONET and make your GPUs count.
Yeah, I think
Last
we can
but
pause
not the least, let's go into
here.
our Explorer.
It's just being mindful of time. But those are the two apps that I showed you out of the three. So that was IO Cloud and IO Worker. What's also really cool that I wanted to re-emphasize is that I've updated our networks that we now support Apple devices as well. And so any Apple device owners can actually now earn on their hardware with IONET. And what's also super cool, I guess it's kind of like a small alpha, but we have a proof of concept that's in the works and a really exciting partnership that's testing out MacBook chips in real AI models. And so we're powering them to with this partnership, a really cool company, they're a generative art startup, and they've been really interested in exploring the potential for MacBook chips as well. And so we're excited to get the ball rolling there and to demonstrate the full capabilities of the new type of hardware that we're supporting. And the final one, I skipped that part just because of time, but the Explorer is where you can see price information on all of our devices. You can also see what devices are currently on our network today. And you can also go through each tab, like clusters, workers, to see non-identifying information of all of the clusters that have ever been deployed on IONET, as well as all of the workers that are on network. The inferences tab is pretty cool. So if you have a model that's powered and your inferencing is powered by IONET, you can also have that inferencing on chain. And so each time a real user runs a prompt to an app, then that's recorded on chain. And then in the future, later this year, we're launching a model marketplace so that model owners can actually start earning on their open source models instead of just having it available and letting anyone use it. And so that's been pretty cool. And those are some of the updates that we have that we couldn't cover here. But thank you so much for listening to my presentation and for listening to the demo. I'm really excited to be here. Our team will also be here all throughout this week. And the next tab has contact information somewhere.